Hello, this presentation is on trigonometric functions of general 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 angles. There are six trigonometric functions, which are sine function, cosine function, tangent, cotangent, secant, and cosecant. General angles include any angle on the circle. Any angle on the circle. So what do we mean by trigonometric functions of general angles? We mean the sine of any angle on the circle, the cosine of any angle on the circle, the tangent of any angle on the circle, and so on. Let theta be an angle in standard position. So let's take a look at the figure. This is angle theta. It is in standard position. What looks like the initial side is on the positive x-axis. Let's use different color. Initial side is on the positive x-axis, and the terminal side, which is the radius in this case, the radius of the circle. The radius of the circle is the hypotenuse of the right triangle, as you see on this figure. So this is the initial side, the radius is the hypotenuse, and the opposite is the distance actually from the x-axis to point P. So as you see over here, the distance from the x-axis to the point P, that's the opposite. Now, this point here, point P, is labeled with two coordinates, x and y. So the x coordinate is the distance from the origin to distance from the origin to this point over here on the x-axis. And the opposite, which is y, since the y coordinate of this point is y, so which means the distance from this point to the point P, that's y, whatever y is. So the opposite is y, and the adjacent is x. Adjacent is x. So if we know the angle theta of the right triangle, we know the adjacent, we know the opposite, we know the hypotenuse, then we can write these six trig functions. Sine of theta, as we see, it should be y over r. Cosecant is a reciprocal of sine, so it would be r over y. And there's a condition here. We say where y must not be 0. Must not be 0. In here, we did not care about the condition because if r is 0, then we have no circle. If the radius is 0, then we have no circle. So there is no need to first define that there is a circle with radius r, and then at the same time, there is no circle and the radius is 0. So cosine, adjacent of our hypotenuse, which would be x over r. Secant is a reciprocal of cosine, so it should be r over x, and the same thing, x must not be 0. Tangent is opposite of adjacent, which is y over x. Cotangent is a reciprocal of tangent, which means x over y. Where, again, y should not be 0, or here also where x should not be 0. Okay. Example 1 says the terminal side of some angle theta. So the terminal side of some angle theta passes through the point 6, comma negative 2. The question says find the 6 trigonometric functions. Let's let's sketch something in here. So this is our circle. If the point, uh, if this point has an x-coordinate 6 and a y-coordinate -2, so let's say 1, 2, 3, 4, 5, 6, and 1, 2, so the point will be somewhere here. Somewhere there, a bit off, but it's somewhere there. So my triangle, right triangle, will be in quadrant 4. This is the angle theta. So now, what are the measures of the opposite, and the adjacent and the hypotenuse? Well, since the x-coordinate is 6, then this point here, so its x-coordinate is 6 and y-coordinate is -2. So that means this segment over here is 6. And this segment over here is -2 because 6 is x and the -2 is y. So 6 -2. Now, we still don't know what the hypotenuse is, so we have to find it using the Pythagorean theorem. So let's label it with c for now. So we say, all right, c squared equals 6 squared plus -2 squared. So c equals square root of 36 plus 4, which is square root of 40. And can we simplify square root of 40? Well, 210. Yeah, 210. So 210 would be same as square root of 40. So it means hypotenuse C is 2 root 10. Now we know the opposite, the adjacent, and the hypotenuse, so we can go ahead and find the values of the 6 check functions. So let's start with the sine function, sine, and then we do cosecant because that's reciprocal. Then we do cosine, and then secant, and we do tangent, and then cotangent. All right, what is a sine? Sine should be the opposite of hypotenuse, which is -2 over 210. And if you rationalize, it's going to be -√10 over 10. The 2 and the 2, they cancel out. So we just rationalize -1 over √10, which becomes -√10 over 10. Cosecant, we said, is reciprocal. So it would be -√10. So I would take this. I would take the reciprocal of this, not the final answer of the sine. Because if you do the final answer of the sine, take the reciprocal of the final answer of the sine, then you have to rationalize. But if you use this expression, then you don't have to rationalize. Right? Okay, let's do cosine. Cosine is adjacent, which is 6, over hypotenuse, which is 210. And then it's 3 over 10. If you rationalize, it's going to be 3 root 10 over 10. Now, with regards to secant, you want to take a reciprocal of 3 over root 10, which is root 10 over 3, to avoid rationalizing. Let's do the last one, which is tangent. Tangent is opposite of adjacent. So tangent is, probably this is the easiest one, -6 over 2. -2 over 6, which is -1 over 3. And then when you do the reciprocal, it's going to be simply -3. So in other words, once we have the measures of the sides, then we can go ahead and find the sine of the angle, the cosine, and everything else. Quadrantal angles. This is more kind of a terminology. We want to be familiar with the word quadrantal. So the word quadrantally means the angles that are in standard position. However, the terminal side is on either the x-axis or the y-axis. So the angles are in standard position, but the terminal side must be on the x-axis or the y-axis for these angles to be called quadrantal angles. So let's look at the definition here. It said quadrantal angles are angles whose terminal side lies on either the x-axis or y-axis. Of course, and I added that the angles must be in standard position. Start with the first one, which is angle 0. The angle 0, it means the initial side and the terminal side are on the x-axis, on the positive x-axis. There is no angle. There is no measurement. The angle is 0. So that's the first quadrantal angle, is 0 degrees. The second one is 90 degrees. So 90 degrees, as you see, the initial side on the positive x-axis, terminal side is on the y-axis, and that's 90-degree angle. Looking at the third one, 180 degrees. 180 degrees, so the initial side is on, again, the x-axis, positive x-axis, terminal side, negative x-axis. So that makes it 180 degrees. And then 270, so the initial side, again, is on the positive x-axis. And then the terminal side, it's on the negative y-axis. And you got this angle all around. And that's 270 degrees. The 360 is the same as a 0. 360 is same as 0 because 360 you're going back to the positive x-axis. So initial the 360, its initial side is the positive x-axis. Terminal side is also on the positive x-axis, same as 0. So let's go back and just check the radian measure for these angles. So 0 degrees is equivalent to 0 radians. 90 degrees is equivalent to pi over 2 radians. 180 degrees is equivalent to pi radians. 270 is equivalent to 3 pi over 2 radians. There's another terminology that we need to know is reference angle. Reference angle is an acute angle. Reference angle is an acute angle formed by the terminal side of an angle and the x-axis. So it is an acute angle, means its measure is between 0 and 90 degrees. What else we need to know about the reference angle? The terminal side of the reference angle has an angle with the x-axis. So it means the angle has to be in between the x-axis and the terminal side. That's the condition. So let's look at the first figure over here. The initial side is the x-axis. The terminal side is on quadrant 1 in here. And the angle in between, obviously, it's an acute angle because it's between 0 and 90 degrees. So that's reference angle is the angle itself. This is special case. The reference angle is the angle itself. And then that happens only if the angle is on quadrant 1. Only if it's in quadrant 1. Now, how about if the angle is in quadrant 2? Look at the second figure here. That's in quadrant 2. Now, can we say that this angle is the reference angle? No, because it's not an acute angle. It's not an acute angle. But if you look at this angle, what is this angle? It is an angle between the x-axis and the terminal side. So this angle is labeled with theta prime. That's a reference angle. Why? Because first, its measure is between 0 and 90, means it's an acute angle. And the angle, it is formed by the x-axis and the terminal. Now, the interesting thing is this angle, theta prime, is equivalent. Let's say this angle is 30 degrees. It is equivalent to 30 degrees on quadrant 1. And that's actually one of the reasons why we want to know the reference angle. Because if we know the reference angle, and we can actually refer back to the angle on quadrant 1 to actually find, for example, the sine or cosine, tangent, cotangent, and so on. We're going to be doing this later on. Now, how do I find the reference angle, which is theta prime? If you look at the figure, the way to find theta prime is this. So this is 180. And this one here is theta. The green one is theta. And the dark red is 180. So how much is this one? Well, if we do 180 minus theta, that is equal to theta prime. So theta prime is 180 minus theta. And if we're using radians, theta prime would be pi minus theta, because pi is equivalent to 180. Let's look at in the case where the angle is on quadrant 3. So in the case where the angle is in quadrant 3, as we see over here, then the reference angle, again, is in between the terminal side and the x-axis. How do I find this angle? Well, this is theta. Oh, I use different color. So this one is theta, and this one is 180. So the orange minus the green, that should give us theta prime. So the angle theta minus 180, that should give us theta prime. So theta prime is theta minus 180, or theta minus pi if we are in radians. Last case, if the angle is in quadrant 4, as you see, if the angle is in quadrant 4, then our reference angle will be this angle, theta prime. How do I find it? Well, this is 360, the entire circle, minus theta. So the green minus the purple or red, it will give us the angle theta prime, this one. So theta prime is 360 minus theta. In radians will be 2 pi minus theta. Example 3 says find the reference angle for each case. 330 degrees. Maybe a graph will help. Okay, that's much better. Okay, all right, great. So 330 degrees. Put the x-axis, y-axis. 330 is definitely greater than 270, but smaller than 360. This is 0, that's 90, that's 180, that's 270, and if you go back to the 0, that's 360. So our 330 must be somewhere. 330 must be somewhere um, over here. Doesn't have to be exact, but this angle theta. Now, what is the reference angle? The reference angle is this one over here, between the terminal side and the x-axis. How do I find it? Well, put reference angle. Let's call it theta prime. Okay? So it would be 360 minus theta. What is theta in this case? It's 330. So 360, or let's do it directly. So it's 360 minus 330. 360 minus 330, which is 30 degrees. Because theta here is 330 degrees. So theta is 330 degrees. Full circle is 360. 360 minus 330, that's equals to 30 degrees. All right, let's do the next one. Next one is negative 300 degrees. All right, let's make another circle over here. Okay, good. Okay. I don't like that. Okay, well, doesn't work. So, negative 300 degrees. Negative 300 degrees. This is 0 if we, I mean, since the angle is negative, then the rotation is clockwise. So 0, negative 90, negative 180, negative 270. If we go back to 0, that's negative 360. So negative 300 must be between negative 270 and negative 360. So it must be somewhere here, okay, approximately. Okay, now how do I find the reference angle? The reference angle is this angle over here. Let's call it theta pi. This is negative 300. So obviously, oh, what is that? Okay, sorry. All right, let's call this theta pi. All right, so let's do this. So obviously, if we subtract 300 from 360, we got the reference angle. So we do 360 minus 300. That is 60 degrees. So theta prime is 60 degrees. By the way, something I forgot to mention, that the angle, reference angle, is always positive. Always positive. Because we want it to be reference angle, we want it to be always congruent to an angle on quadrant 1 in absolute value. Congruent in absolute value. So it has to be positive. Okay. 4 pi over 3. Let's make another circle. Okay, good. So 4 pi over 3, we're not yet really familiar with the Eden measure, but let's try. The pi over 3 is equivalent to 60 degrees. So it means 4 times 60 degrees. 4 times 60 degrees. Okay? 4 times 60 degrees. So I keep forgetting this. Okay. 4 times 60 degrees. So that means I can actually go 60 degrees plus another 60. That makes it 120 plus another 60. That's 180 plus another 60. That's 240. So it means pi over 3 plus another pi over 3. That's two of them. 3 pi over 3, and then 4 pi over 3. So 1 pi over 3, 2 pi over 3, 3, 4. So the most important is information is this quadrant is this angle is in quadrant 4. So quadrant 4, right? Quadrant 4. So this is 4 pi over 3. Now how do I find the reference angle? Well, reference angle is in between the terminal and the x-axis. Let's call it theta prime. So what we're going to do is we're going to do theta prime equals 4 pi over 3 minus pi, because it's the entire green angle minus 180 or minus pi. That will give us theta pi, the reference angle. After we find the common denominator, this is going to be pi over 3. Let's do the next one. Negative 5 pi over 4. So negative 5 pi over 4. So pi over 4 is 45 degrees. Negative, it means, is clockwise rotation. So we start from 0 and we go 45, which is halfway 90. So 45, how many 45s we have? We have 5. 5 times pi over 4, which means 5 times 45. So 1, 2, 3, 4, 5. So our angle is this one. What is our reference angle? It's in between the terminal and the x-axis. Let's call it theta prime. Theta here is negative 5 pi over 4. So how do I find the angle theta prime? It would be theta minus theta or plus pi, because the angle here is already negative. So we do theta prime is negative, we do 5 pi over 4 minus pi, which is pi over 4. Now, here's a check. There's a check on how to find the reference angle if the measure is given to us in radians, which makes it very easier than actually finding a reference angle of an angle that is given in degrees. Here's the thing. If you notice, for the reference angle of 4 pi over 3 is simply pi over 3. It means you just ignore the coefficient of the numerator, of course. The coefficient on the numerator. So if you ignore the coefficient, what's left is pi over 3. If you ignore the coefficient here, what's left is pi over 4. It will always work this way. You ignore the coefficient, whatever remains, that's your reference angle. So it's easier than actually if the angle is in degrees. So the next concept is about whether a given trigonometric function is positive or negative at any given quadrant. So positive, negative trigonometric functions on each quadrant. So let's start with labeling quadrants. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. In quadrant 1, if we pick a point on the circle in quadrant 1, so I take this point here, we know that the x coordinate of this point is positive, and the y coordinate of this point is also positive. If we pick a point on quadrant 2, then the x coordinate of this point is negative. The y coordinate is positive. Then on quadrant 3, the x coordinate is negative, the y coordinate is positive. Quadrant 4, the y coordinate is negative, sorry. Y coordinate is negative. Quadrant 4, the x coordinate is positive, and the y coordinate is negative. So let's verify again. First quadrant, first point, first quadrant, point on the circle in the first quadrant, x is positive, y is positive. Second quadrant, x is negative, y is positive. Third quadrant, x is negative, y is negative. Fourth quadrant, x is positive, y is negative. Now, if I draw a triangle on quadrant 1, then the opposite must be positive. The opposite um, of angle theta is positive. It's above the x-axis plus the y-coordinate is positive. The x, or is the adjacent, is positive. The hypotenuse will always be positive, so probably we don't have to put a sign next to it. The hypotenuse is always positive. Why is that? If we pick a right triangle and label the adjacent of angle theta with A, opposite with B, and hypotenuse with C. So to solve for the hypotenuse, what you have to do is you use Pythagorean theorem. So you do c squared equals a squared plus b squared, and then c is square root of a squared plus b squared. Now a squared is positive because any number squared is positive. B squared is also positive because any number squared is positive. A positive number plus another positive number that must be positive. And we take square root of a positive number, the answer will be positive. So therefore C will always be positive. So the second quadrant, we draw a triangle in second quadrant. The opposite is positive and the adjacent is negative. On the third quadrant, the opposite is negative, adjacent is negative, and then the fourth quadrant, opposite is negative, adjacent is positive. Okay, now we can easily determine if the sine function, for example, quadrant 1, is it positive or negative, is the cosine positive or negative, and so on. So quadrant 1, we know that the sine is opposite over hypotenuse. So hypotenuse we said is always positive. Plus hypotenuse in this case is the radius of the circle, and the radius of the circle will always be positive. So it means whether the sine or is positive or negative on quadrant 1 that would depend on the opposite. So in quadrant 1, the sine is opposite over hypotenuse, which means plus over plus. So the sine is positive, quadrant 1. So let's make a list, or let's put positive functions. Don't have space in here, let's do this. So quadrant 1, do a Q quadrant, quadrant 1. Positive function. So the sine is positive because sine is the opposite of hypotenuse, and the opposite is positive. The cosine is also positive because cosine is adjacent over hypotenuse. Adjacent is positive. And then the tangent is also positive because tangent is opposite of adjacent. Both opposite and adjacent are positive. And then all the reciprocals are positive. If sine, cosine, and tangent are positive, then the reciprocal must be positive, which is cosecant and secant and cotangent. So all the functions in quadrant 1 are positive. In quadrant 2, if you look at the purple triangle, the sine again is opposite of hypotenuse. Opposite is positive, so the sine must be positive. Sine must be positive. So let's put a plus. Sine is positive. Cosine is adjacent to the hypotenuse. Adjacent is negative. So the cosine is negative. Tangent is opposite of adjacent, plus over minus. Plus over minus is minus. So tangent is negative. Now we know sine and cosine, sine, cosine, and tangent. We can easily determine the cosecant, secant, and cotangent. So the cosecant is a reciprocal of sine, so it must be positive because sine is positive. The secant is a reciprocal of cosine, so that must be negative. And the cotangent is a reciprocal of tangent, it must be negative. Let's look at quadrant 3. Quadrant 3. Sine is, oh, forgot to put theta, theta, and angle theta. So let's go over quadrant 3. The sine is opposite of the hypotenuse, so opposite is negative, so the sine must be negative. Let's put a plus, minus, so sine is negative. The cosine is adjacent to the hypotenuse, so that's also negative because adjacent is negative. Tangent is opposite of adjacent, so minus over minus, so tangent is positive, minus over minus is plus. So we got sine, cosine, and tangent, so it means the cotangent is also positive, and cosecant and secant are negative. Quadrant 4, look at the triangle. We want to know which of the functions are positive, which ones are negative. So sine is opposite of the hypotenuse, opposite is negative, so the sine must be negative in quadrant 4. Um, the cosine is adjacent of the hypotenuse, adjacent is positive, so the cosine must be positive. Tangent, opposite of adjacent, negative over plus, that's a negative, so tangent is negative. Alright, secant is a reciprocal of cosine, and then cosecant and cotangent. So cosecant and cotangent are both negative. So another trick is you look at the x and y coordinates at each quadrant. So the cosine will be the adjacent, it means it will be the x coordinate. So it will be plus. The sine is the y coordinate, in this case is plus. So the cosine is positive, and the sine is negative. Cosine is positive, sine is positive. Did I say negative? Sorry. Cosine is positive, sine is positive. Cosine is negative, sine is positive. Cosine is negative, sine is negative. Cosine is positive, sine is negative. And then what is tangent? Quadrant 1, tangent is sine over cosine, and so on. So this is how we determine the whether the a given function, check function, is positive or negative at a given quadrant. Let's fill in this table. So let's fill in this table. On quadrant 1, we know that the sine function is positive, its reciprocal is positive, cosine is positive, its reciprocal is positive, tangent is positive, its reciprocal is positive. Quadrant 2, sine is positive, cosecant its reciprocal of sine must be also positive, cosine is negative, then therefore the secant is negative, tangent is negative, therefore cotangent is negative. Quadrant 3, sine is negative, its reciprocal must be negative, cosine is negative, its reciprocal must be negative, and the tangent is positive, its reciprocal must be positive, cotangent. So quadrant 4, the sine is negative, reciprocal is negative, cosine is positive, its reciprocal is positive. Tangent is negative, its reciprocal is negative. So on quadrant 1, all the functions are positive. On quadrant 2, only the sine function and of course its reciprocal are positive. Quadrant 3, only the tangent and its reciprocal are positive. Quadrant 4, only the cosine and its reciprocal are positive. Example 4 says, for an angle theta in standard position, the sine of this angle theta is root 2 over 2, and the tangent is -1. Can the value of theta be 225? Justify your reasoning. Okay, we must make a figure for this. It says the sine is root 2 over 2. That means the sine is positive. We said the sine is positive on quadrant 1. Sine is positive on quadrant 1. And the sine of positive is on quadrant 2. Now the tangent is negative. So this is the sine. It's positive. Sine is positive on quadrant 1 and quadrant 2. The tangent says here equals -1. So tangent equals -1, it means tangent is negative. We said the tangent is negative on quadrant 2, tangent negative, quadrant 2. Also, the tangent is negative on quadrant 4. Tangent is negative on quadrant 4. And this is quadrant 3. Well, here's the problem. The only quadrant where both the sine is positive and the tangent is negative. So the sine is positive, tangent is negative, is in quadrant 2. Not in quadrant 1, not in quadrant 4. So can theta be 225? Well, obviously not, because 225, that's on quadrant 3. 225 is in quadrant 3. What's in quadrant 3? Quadrant 3, the sine is negative, and here it says the sine is positive. That's already not, that condition is not satisfied. And the tangent actually in quadrant 3 is positive, which is the opposite of the given tangent, which is negative. So we say, well, this is not possible. 225, or we say theta cannot be 225. So the value of theta cannot be 225 because 225 is on quadrant 3, where sine of theta is negative and tangent of theta is positive. However, sine theta equals root 2 over 2 is positive, and tangent of theta equals -1 is negative. So they don't match. Example 5 says, give an example of a negative angle theta. So give an example of a negative angle theta for which sine of theta is positive and a cosine is negative. So let's make a figure and then we can figure it out. So sine is positive on quadrant 1 and quadrant 2. Cosine is negative. Cosine is negative on quadrant 2. So cosine is negative on quadrant 2 and quadrant 3. And quadrant 3. So it says give an example of a negative angle theta for which the sine is positive and cosine is negative. So it must be quadrant 2. Because we see like both the blue and the red circles are on quadrant 2. So we need both of them to be in the same quadrant. So give an example of some angle theta. Well, there are too many. We can just give one example. This is negative 180. If we add a little bit, you can add 10 degrees, 20 degrees, 30. You can add 1 degree, whatever you want. So let's say negative 200 degrees. Okay, negative 200 is an example. So the answer here can differ from one person to another. Example 6. Suppose theta is an angle in standard position. That means its initial side is positive x-axis, terminal side starts rotating from the initial side. So suppose theta is an angle in standard position whose terminal side is in the given quadrant. For each function, find the exact values of the remaining five trig functions. So example A, example A? We're given a tangent of theta, which is negative 2 over 3, and this is in quadrant 4. Okay, let's show figure. Quadrant 4, this is quadrant 4. This is quadrant 4. Okay. Here's a triangle. Let's make triangle there. Let's put theta. Tangent theta is negative 2 over 3. This is negative 2, and that's 3. So negative 2 has to be the opposite because the opposite here, it's below the x-axis. It is the one that is negative. The opposite is below the x-axis and has to be negative. The adjacent has to be the positive number 3 because it's in the positive x-axis. So it's negative 2 over 3 because tangent is opposite of adjacent. So we don't know what the hypotenuse is. We can solve for it. Let's call it c. And then we just use Pythagorean theorem. So we say c squared equals 3 squared plus negative 2 squared. So c is the square root of 9 plus 4, which is square root of 13. Square root of 13. So now we know that c is square root of 13. Hypotenuse is square root of 13. Okay. Can we find the other functions? Certainly. The easiest one to find is cotangent. Why? Because we already know tangent. Cotangent is reciprocal of tangent, so negative 3 over 2. Okay, that's done. Now let's do sine. What do we know about sine? Sine is opposite of hypotenuse, so it's negative 2 over root 13. And then you have to rationalize. So it's negative 2 root 13 over 13. Which one is the reciprocal of sine? Reciprocal of sine is cosecant. So let's just take a reciprocal of negative 2 over 13, which is negative root 13 over 2. Let's do the next one, which is, so we did cotangent, we did sine, cosecant, we need cosine. Cosine theta, cosine is adjacent over the hypotenuse, so it's 3 over root 13. Rationalize 3 root 13 over 13. 3 root 13 over 13. And then its reciprocal is secant, so we do secant. Take a reciprocal of 3 over root 13, so we'll be root 13 over 3. Because we don't want to do a lot of work by rationalizing. All right, let's move on to the next one, which is the last example. Last example, the sine of the angle theta is 4 over 5, quadrant 2. Quadrant 2, draw a triangle, angle theta. Sine of angle theta is 4. Sine is opposite over hypotenuse. So opposite, which is 4, hypotenuse, which is 5. Okay, good. Now we're missing, let's call this side B. We need to find B, okay? So we use Pythagorean theorem. We say, okay, B squared plus 4 squared equals 5 squared. So B squared equals, 5 squared is 25, 4 squared is 16, 25 minus 16 is 9. So B equals 3. No, sorry. B B in pure math, which is going to say plus or minus square root of 9, which is 3, correct? However, we got to decide, is it 3 or negative 3? Well, it's negative 3 because B here, it's on the negative x-axis. So it has to be negative 3. So let's take out the plus. Okay, so B is negative 3. Negative 3. All right. Now we can find the cosine, cosecant, tangent, everything else. So we know the sine, so the easiest function to find, since we know the sine, is the cosecant. Cosecant is the reciprocal of sine, so it's 5 over 4. Now let's move on to cosine. Cosine is adjacent, which is negative 3, over hypotenuse, which is 5. What's the reciprocal of cosine? Is secant. Reciprocal of negative 3 over 5, that's negative 5 over 3. Let's do tangent. Tangent is the opposite, which is 4, over adjacent, which is negative 3. Cotangent, reciprocal of tangent. Reciprocal of 4 over negative 3 is negative 3 over 4. And with this, we have found the remaining 5 trig functions. I hope you enjoyed the presentation. Thank you for watching.